With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I hope you all are doing good. Today our question is like this. We have which one of the following statements is not correct? We have different statements which we have given in the options, and we need to identify which of the following option statement is not correct. Our first statement is like this. Tyndall effect in colloidal solution is due to scattering of light. Hardy-Schulze rule is applicable only to the coagulation of lyophilic salts. It will be Hardy-Schulze rule. Okay. Blue color of sky is due to scattering of light by dust particles, and our final option is greater flocculation value of an electrolyte means its poor coagulating power. Okay. So these are the basic options. So our first option is Tyndall effect in colloidal solution is due to scattering of light. So this is the basic definition of Tyndall effect. What is Tyndall effect? When we pass a strong beam of light through the colloidal sol placed in dark, when we pass a strong beam of light through the colloidal sol which placed in dark, or we can say which placed in the dark place, then the path of that beam will get illuminated, and this phenomena is known as Tyndall effect. Okay, and this phenomena is known as Tyndall effect, and this illuminated path of the beam is due to scattering of light. This illuminated path of the beam is due to scattering of light. So what happens when a beam of light like this, we have a beam of light from sun, light from sun, we have like this, we have a beam of light, and this is a colloidal sol. This is a colloidal sol placed in front of the source of light. Okay, this is the colloidal sol which placed in front of the source of light. Okay, so when this beam of light will pass through the strong beam of light is passed through the colloidal sol, then the path of the beam will get illuminated. Then the path of the beam will get illuminated like this. Okay, and this path, this illuminated path is due to scattering of light like this. The light get scattered by the colloidal particles. The light get scattered in the different direction. The light get scattered in the different direction by the colloidal particles, and this phenomena is known as Tyndall effect. And this phenomena is due to scattering of light by the colloidal particles present in the colloidal solution. Okay, this scattering of light, or we can say the path of the light will get disturbed, or we can say the path of the light will get illuminated due to the scattering of light by the colloidal particles present in the colloidal sol. Okay, and this phenomena due to scattering of light from the surface of these colloidal particles is known as Tyndall effect. So our first option is the correct statement, and this is a very basic definition of Tyndall effect. And example of this Tyndall effect is blue color of sky. Blue color of sky. This is the example of Tyndall effect. Why the sky appears blue? Because there is a scattering of light takes place by the dust particles present in the sky. These dust particles are the colloidal particles. These dust particles are the colloidal particles, and by these dust particles the light gets scattered. The light gets illuminated. The path of this strong beam of light will get illuminated. So blue color of sky is due to scattering of light by dust particle. This is the very basic example of Tyndall effect. So this statement is also true. This statement is also correct. So what are the examples of Tyndall effect? We have blue color of the sky and sea water. Why sky appears blue? Due to scattering of light by the dust particles, and these dust particles are the colloidal particles. When the strong beam of light pass through these dust particles, this strong beam, the path of this strong beam will get illuminated, and this illuminated path is known as Tyndall cone, and this illuminated path is due to the scattering of light by these colloidal particles which are dust particles. Okay, I hope you guys are understanding it. Okay, so this first option and third option is the correct option, and this blue color of sky is the basic example of Tyndall effect. We have another example like visibility of tail in comets. Okay, visibility of tail of comets and appearance of dust particle in semi-dark room. This is also an example of Tyndall effect. Also light thrown from a projector in cinema hall. When we throw a light to the projector in cinema hall, then we also can see the Tyndall effect in this phenomena also. Okay, so when we throw a light from a projector in the cinema hall, then we can easily observe the Tyndall effect. We can easily observe the Tyndall effect. The light will get, this light, when we throw the light from the projector, this light will get scattered by the dust particles present in the air. When placed in the cinema hall, when placed in the dark, this light will get scattered by the dust particles. Okay, so this is a very basic example of Tyndall effect. So first and third option is the correct statement. Our second option is Hardy-Schulz. It is the Hardy-Schulz rule. Hardy-Schulz rule is applicable only to the coagulation of lyophilic salts. This statement is the incorrect statement. This statement is the incorrect statement because Hardy-Schulz rule is applicable both for lyophilic and lyophobic salts. What is Hardy-Schulz rule? I hope you know the Hardy-Schulz rule. Hardy-Schulz rule is the basic rule when greater the valency of coagulating ion. This Hardy-Schulz rule is the basic rule for the coagulating ions. That means it says that greater the valency of the coagulating ion, greater will be the coagulating power. Greater the valency of the coagulating ion, then greater will be the coagulating power of this. Okay, I hope you understand it. So this statement is incorrect, that Hardy-Schulz rule is only applicable for coagulation of lyophilic salts. It is applicable for both lyophilic and lyophobic salts. Okay, and what is Hardy-Schulz rule? Hardy-Schulz rule is this, according to this rule, greater is the valency of coagulating ion, greater is its power to cause precipitation, or we can say greater the valency of coagulating ion, greater will be the coagulating power. This is the basic Hardy-Schulz rule. That means higher the valency, like we have FeCN6 minus 4. We have an ion like this, FeCN6 minus 4. We have PO4 minus 3. And we have SO4 minus 2. And also we have Cl minus. What is Hardy-Schulz rule? Hardy-Schulz rule says that higher the valency of coagulating ion, higher will be the coagulating power. Here valency is minus 4, here is minus 3, here it is minus 2, here it is minus 1. So higher the valency of coagulating ion, higher will be the coagulating power. So this is the order of coagulating power, because this is according to the higher the valency, higher will be the coagulating power. So this is the basic Hardy-Schulz rule, and it is applicable for both lyophilic and lyophobic salts. Okay, order of coagulating. Wait a second, let me correct this spelling, guys. Order of coagulating power. So our option second is the incorrect statement. Now our final option is like this: greater the flocculation value of an electrolyte means its poor coagulating power. So this is the correct statement, and this is a very basic statement. What does statement it means? This statement means that when we have higher coagulation value, that means it have poor coagulating power, and this is according to this basic relation like this: coagulating power directly, it is inversely proportional to the coagulation value. Coagulating power is inversely proportional to the coagulation value, and this coagulation value is also called as flocculation value. Okay, so our option 4 statement is correct statement, that higher the flocculation value means poor its flocculating or coagulating power. Okay, so our incorrect statement is, the statement which is not correct is option second statement. So our correct option for this question will be option second. Our fourth statement is also correct, that we know coagulating power is inversely proportional to the coagulation value, or we can say floculating power is inversely proportional to the flocculation value. So greater flocculation value of an electrolyte means poor coagulating power or poor flocculating power. Okay. So our correct option for this question is option second. Thank you guys.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.